Okay, my name is Van Chestnutt, and I am the president and founder of a company called Tirraappendi. We're based in Redmond, Washington, and Tirraappendi is an interesting word. It's an Australian Aboriginal word. It means to protect. I got the name a few years ago because I had Motorola in Australia doing a project for me, requirements definition, and that was the code name that they gave the project. And then when I got the company going, I liked the name so much, I said, let's keep it. So that's where Tirraappendi actually came from. So let's jump into this. Essentially, the situation is there are bad guys out there. They want to take your stuff and they want to use it, generally to their advantage, not yours. Essentially, things go missing. Whether it's intentional, someone stole it, or it just got lost, or it was accidentally destroyed, but things go missing. Electronic equipment gets misplaced, it gets stolen, and it gets misused. Electronic assets need to be protected, and they need to be controlled. In the words of Martha Stewart, would it be a good thing if we were able to manage our electronic assets remotely? And by remotely, I mean almost anywhere without human touch. So here are some few examples of security breaches. So we had security breaches at Sony, Home Depot, and Target last year. In 2009, the Wall Street Journal reported that cyber spies had penetrated the US electrical grid. Not a good thing. In 2005 and 2006, Boeing had some laptops that went missing that had former and current employees' personal data on it. I was one of them. I was concerned. In the past decade, there have been several data security breaches at Los Alamos. I originally thought that this was just 2 or 3, but actually it was a number of them. I mean, 5, 6, 7, 8, 9. And this is the one that is the most concerning to me because this is where the nation's nuclear and energy-related research is done. One of the ones that I do not have up here is the Snowden breach, for lack of a better term, where laptops containing sensitive information were appropriated by Edward Snowden and he left the country. One of the things that I do not know is what actually happened at the command center when he took the equipment. How long did it take before they knew that the breach had occurred or that he had absconded with the laptops? Our solution is something that I called T-Secure. T-Secure is a patented, tamper-resistant security component, that means hardware, for remotely disabling and enabling or controlling certain types of electronic equipment. Things that are microprocessor or microcontroller based. I'm not talking about cell phones and I'm not talking about PDAs or that type of thing. T-Secure may be used for both physical security and asset management. And what that means is I can disable equipment while it is in transit and re-enable it once it gets to its destination. T-Secure can shut down equipment, prevent future startup, and be used to protect data. The key elements of T-Secure are that it is incorporated into the power-on self-test of equipment. Almost everything that's electronic has a power-on self-test that it goes through when you turn it on. That means it checks for things like in a laptop, is there a hard drive? Is the operating system in place? Is the BIOS working? So this operates at the most basic level of a device. Are all the components there and do they work? So in essence, what we're doing is talking to the post via our RF signal and sending a signal or telemetry to say, shut it down or enable it, or in some cases, drop the encryption keys. How is the communication handled? Like I said, it's through RF. For military, military applications, this is going to be quite broad. They may have several different techniques that they want to use or employ for different types of equipment. It could be for weapon systems, or it could be for other types of devices. Satellite is another option. AM and FM signals, you can embed certain types of signals in those. When I originally developed this, I had laptops in mind, and I was going to use paging signals. And I believe that you can embed a paging signal inside AM and FM broadcast. So in that regard, you could handle it even in Africa or remote areas where they just have AM radio. One of the other key elements is this is a passive technique. So it really doesn't have to have an electronic handshake. An electronic handshake is when you send a signal to a device like the laptop, and the laptop responds like, yes, I am here. So this can be passive or not. It all depends on what the customer requires. And it does create remote control of a device. So here's a process diagram, how it would be used. The user or the owner discovers that their equipment is missing. They call or notify the security organization or help desk, and the help desk, as step 2, they validate the user and they identify the equipment that is missing. And step 3 is they launch some sort of broadcast to broadcast the message that goes out over the airwaves to disable the equipment. The devices, all the devices that have the chip in it of that certain configuration, receive the signal. Then the last thing that happens is the device determines, is this signal for me, yes or no? And if it does, then it performs the command that was requested. So here are the advantages. It's a remote control. It's discrete. It can be either covert or overt. And by covert, it might be embedded in equipment with no outside indication that the T-Secure chip is embedded. And that means you could turn things off and all of a sudden they just don't work anymore. Then if you try to reboot it, because it's embedded in the power on self-test, it's not going to come back alive. In the case of the laptop, when we did our initial test, we just created the blue screen of death and it shut down, and you were never able to get it to power back up again. So there's no internet connection required because it's using RF. You can't really boot around it with a USB or other media because it's part of the power on self-test. And in order to boot up something with a USB or a CD or something, you need to have the operating system working. And if you can't get the operating system to work, it's a boat anchor. As a result, you can't really hack the operating system to circumvent it. When the equipment validates, there's internal validation that goes on to make sure that the chip has not been circumvented. In other words, you can't take the chip out and the device will work. You can't take a chip that has not been disabled and put it in the same place and expect it to work. That won't work either because of this internal validation. The equipment does not have to be turned on to be secured. With micro batteries like you have in hearing aids or trickle energy sources, the battery that is in like a laptop could go for months, in some cases years, and just receive the signal, and you would never have to worry about that type of problem. Let's see what else. I've tested this with a GPS, and a few years ago, GPS technology was improved such that you could actually get, if you had the right type of GPS chip, a signal in a building like this where you have several layers of concrete and metal above you. And I tried that and it did work. In the case of like a laptop or something where you have data on there that you want to protect, you can drop the encryption keys. And if you drop the encryption keys, it's pretty much toast. So you could keep the equipment alive, but you could disable it or destroy the data by dropping the encryption keys. You could also cause a device to self-destruct. Another thing that you could do is, oh, I already mentioned that. Anyway, there are a variety of applications. The potential users in the military are obviously the US Army, Department of Defense, Air Force, Marines, even the State Department. OEMs, original equipment manufacturers, would, generally speaking, incorporate this in the manufacture of the product. You could, however, have a retrofit kit where you could embed it after the equipment was deployed in some situations. Other OEMs would be laptop manufacturers and manufacturers of military and government equipment. You could have this as non-ordnance military equipment too. One of the examples that came up in discussions last year was perimeter security. Apparently on bases around the world, there are guards that are using specific perimeter security device that are attuned for bases when they go on guard duty. And they use these devices to open accesses through gates, etc. You don't want those devices to fall into the wrong hands. But if you had one of these and it had a T-Secure chip in it, you could disable that remotely, regardless of where it was. Application-specific issues. If you were to employ T-Secure, you would have to, based on the application, define the communication technology to be used. You'd have to define what specific engineering capabilities would have to be employed. That involves the chip design. And you'd have to decide whether or not you want to incorporate GPS. Now, if you do GPS, that does imply a handshake so that the equipment is telling the network where it is. And I've also had a few ideas on how this could be employed for aviation, specifically for helicopters and other avionic systems. So our objective, because this isn't a real flushed out thing yet, is we are seeking to find a customer or a partner to work with to further develop the technology. And the goal is to eventually license the capability. Thank you. Now, I have a demo. This is a simulation. It's not very exciting to see a computer shut down, but that's what I'm going to show you. In my, can you switch this? Not really. So I'm not going to show you shut it down. But what I would do is I would dial on my phone, SkyTel, for example, tell it the name of my device, and then enter the code for shutdown, and it would just turn it off. It just shuts it down, and it would not be able to come back on. Now, questions?
Hi, thanks. So Tom LaFleur, I run Future Warfare for the Army's Future Center.
Okay.
This has potential for incredible offensive capability to include sabotage. This is a really interesting technology that isn't just a defensive piece. Have you been approached by that?
No.
Okay, I'd like to talk to you about that afterwards.
Okay. Let me give you another thought. So one of the issues, particularly with the Los Alamos situation, is when you're talking data breaches and someone takes over your computer, like specifically servers, often you know there's an attack going on, but you can't do anything about it because the perpetrators of the attack lock up the servers and they won't respond. You try to do a VPN connection or you do a remote data connection to the servers. They cannot respond. But in this way, you're coming in behind the scenes and you're talking to the operating system and you can shut it down. So that's one of the unique features of being able to do this. You were going to ask something, Bill?
Yeah, I go back to the handshake. I understood you recognized the handshake requirement for GPS, but if I have a missing piece of equipment, I hit or call and say, hey, disable this piece of equipment, do I want to make sure that that handshake happened so that, okay, I can feel comfortable that the equipment was disabled? So just kind of figuring out, and on your requirement side, I think you may want to consider, even in a non-GPS connectivity, is that you want a handshake.
So when when I was originally playing with this, I was using a paging chip.
Right.
And the paging chip, there were two different kinds. Essentially, there's reflex and reflex technology. Reflex requires a handshake. Well, it doesn't require, but it allows for it. And other types of paging signals, it's just one way. Like, for example, when in years ago, when doctors would carry pagers, you couldn't ensure the receipt.
Right.
So in that situation, you might broadcast several times or several different ways to make sure that the device was reached. In the case of data destruction, because you had to bug out in MASH terms, and you had to leave data behind, and you didn't want to send people into harm's way to go retrieve that equipment, you might be able to ensure that it was received because something went boom in the distance.
Right. And I don't know, what does Apple do? So I've had the experience on a LoJack and an Apple. My car was stolen, but my briefcase was in the car, my computer was in my briefcase. I called the dealership and I said, hey, can you track my car? They said, no, you didn't turn on the LoJack. What do you mean I didn't turn on the LoJack? It's a $75,000 car. Well, you didn't do it. So then I looked in my iPhone and said, find my computer, and there it was, and that's where the car was. And I immediately disabled my computer. Now I know LoJack, you can actually disable the car. So those are the kind of concepts, you know, from a defensive standpoint, those are the type of things is we want to say, yes, the signal was reached, and I can feel comfortable, whereas I know I don't have my computer, but I can tell you that nobody can get that data, versus just pressing the button or sending a signal and just hope that it had happened. Mm-hmm. So that's...
Yes, that has come up a couple of times. Do you want to know, yes, or do you just want to broadcast repeatedly, or how do you want to do this? And that's in the requirements definition for each particular instance.
Right. So what we've got to do, and I'm glad the Colonel's here, is find you the guys who can help define those requirements.
And it's, like I said, it's going to be unique requirements for almost each application.
Yes. Okay. Thank you, sir. Any other questions?
Anything else?
Okay. Our next presentation from Torrey Pines Logic, we're going to